Okay, so in order for you to find an inverse, again, for our equations, we switch to x and y and then we solve. For our tables, our original table, to find its inverse, we just switch to x and y values. And for our graph, right, if we plotted the original points, and then we just switch them for our inverse. Questions on what an inverse is and how you find an inverse? Yes? Yep, that's all. I find a lot with inverses, people want to do a lot more steps, right? You get to the point where you're like, is that it? That's it. You're just switching the values. Any other questions? All right, so we're going to practice finding the inverse. I found that worksheet, I'm looking at it, had a lot of fractions, and it had some radicals that we never got to because we went distant learning for those 2 days we were going to go over radicals. So some of those problems I'm sure were very complicated. So I figured we get some practice with some regular old linear functions, linear equations. So what do I do with this? This first one. I can't hear you. Yep, how do I find the inverse? Switch to what? Switch to x and y. Then what? Yes. Subtract instead of add. So this is a one-step equation, right? We're going to name this g of x because it's going to come in handy later, right? This is a one-step equation. One-step equation should be just that easy. And again, remember, I only use easy very lightly. One-step equations shouldn't take you much long. If they are, and that was complicated, you need to reach out to me so I can give you some practice. Or you need to go, I've said this before, it's also an app on your phone. I think it's not working. It's also an app on your phone. You can download it and you can practice. I know we don't want to sit around and do math all day. 5 minutes of practice every day will increase your skills. Okay, so now domain. We talked about domain, and for a linear equation, every single time the domain is the same. What is it? Do you remember? Domain. We said that for a linear equation, the domain is the same every time. Yes? It's the x. Anybody remember what a domain is? No? The what? The what? The x values, yep. So what can go into the x value of a function tells you what the domain is. So we did all 2 days on just domain and range. You have a project coming up at the end of October. You have to say the domain and range. Well, what is domain for this? What values can go into this function? Yeah. I can't hear you. 4? What else? What else can go into this function? She said 4. Yes, 4 can go into this function. What else can go into this function? 2. What else? 6. Anything. Anything. All real numbers can go into this function. There is no number. We're going to get to equations where that's not going to be true. But for this equation, can you not see that? All real numbers. You can kind of like, if you want to move your desk over a little bit. Okay? All real numbers is also written as negative infinity and positive infinity. All real numbers. Yes.
This is for negatives, negative number.
Can you put a negative in here? Negative 12 plus, negative 12 minus 4. Are you going to get a number? So, yep, you can use negatives. Can you use 13? 13 minus 4. Is that going to give you an answer? So that's how you figure it out. You actually say it to yourself. All right, the next one. Before we start to solve for anything, what do we need to do? This is not written in correct format. What do we need to do before we can start? Somebody said divide? No. Nope, before we switch to X and a Y. Simplify, yep. Before you can start, you only want to make sure your equation is written in simplest form. If it is not, you're going to do extra steps within your solving, and you don't want to do that. So if you start off with something in simplest form, you do less steps in the end. So, now you already told me to switch my X and Y. So again, now that there's more than one step, I'm going to write my story out. Because I don't want to mistakenly do the wrong step. So, my story of Y. What's happening to Y right now? Y is being what? Excuse me? Right now, I just rewrote this same equation over. That's all I did. What's happening to Y? Y is being what? Subtracted by? And then what's happening? Divided by 5. So, when I want to do my inverse, I'm going to go backwards with my inverse operations. So instead of divided by 5, I'm going to, instead of subtracting 2, I'm going to. So now I'm going to apply these steps to my inverse function. So I want my x. How do I show multiply by 5? We're doing it. 5x. How do I show added 2? Alright? So this becomes my inverse function. And so this is a linear function again. So what's my domain again? All real numbers. Every time you hear linear function, you gotta just say it out. All real numbers is your domain. There's no parameters on a linear function. Everything can go into a linear function. It's a straight line that goes all x's. Questions on this one? I'm just going to rewrite it inverse here. What do I need to do to the last one before I start? Yes. Simplify. How do I do so? Distribute. So you want to distribute first. I'm going to go upwards with the. And then what do I want to do? I get 4x minus 8 minus 12. Now I want to combine my terms. I see your area. Right? So our original function is going to be 4x minus 20. Yes?
How do you get 8?
4 times 2.
So the 4 stays there?
The 4 got multiplied to the x, 4x, and the 4 got multiplied to the negative 2. So now what's my next step? Or so what's my first step in finding the inverse? What's our first step in finding the inverse? Switch the x and the y. Somebody said write a story. So what's the story? What's happening to my y? It's being multiplied to 4 and then subtracted by 20. So when I go to find the inverse, instead of subtract 20, I'm going to, instead of multiply by 4, I'm going to, so I'm going to apply my steps. Here's my x. I'm going to add 20. I'm going to divide by 4. However, remember, when it can be simplified, it must be simplified. So, I'm going to draw that inverse function g of x. I'm going to get x over 4. 20 divided by 4 is 5. And even though there is a fraction that x is in the numerator, all positives can go in the numerator, all negatives can go in the numerator, and a 0 can go in the numerator. So it's still all real numbers for the domain. Anybody still copying? Yeah, I see a couple more people. Yes. Say it one more time. I use G to describe all the inverse functions. Just because I did. I just randomly picked G of x. Yes. 20. This original 20. Remember at the beginning I had to simplify, so I did 4 times x and 4 times negative 2. Right? So then I have to combine my terms. Negative 8 and negative 12 is negative 20. Make sense? Did I answer your question with the G? Did we understand that? Okay. I just called them all G because I'm going to make you do a composite function, and it's easier if it's a function already. That's all. So we're going to call all the original functions. Change that. Change that. We're going to call the original functions nothing because that doesn't work. F of x. And so now I want you to prove that they're inverses. How do we prove that they're inverses? Nope. How do we prove that they're inverses? If you get the input, what do you have to do to get the input? What are you doing to get the input? Starts with a C. Composite. So we're going to do composite functions. We're going to composite f of g every time. And we're going to make sure we get back our input. What is our input for all these functions? Right now, what is our input? X. So we want f of g every time to equal x. Okay? So here, we're going to do f of g of x. And we're going to do f of g of x. I'm going to do the first one with you, and then I'm going to have you do the last two by yourself. Okay? So, I have my x function. And instead of my x, I'm going to replace it with my entire g function. Okay? So, here's where my x would have been. I put my entire g function in there. I simplify by getting rid of the parentheses. There's nothing to multiply out. I combine like terms. -4 plus 4 is 0. So my f of g of x, the only thing left is my x. So inverse proven. Yes. So the goal is you take the composite of the inverse, and you should always get back the input. So try it with the second function. About 1 more minute. Bless you. Okay. So I'm gonna take, just for the sake of space, I'm gonna do it over here so I can have this whole thing right now. So I'm gonna take my f function, right? And instead of my x, I'm gonna replace it with my entire g function. So then I get 5x plus 2 minus 2. And then I combine my terms. So the plus 2 minus 2 cancel out. And I know you can't see the back, so I'm going to continue it over here. So then we get 5x over 5. But then the identity property of division cancels those out. So then you get g of x composite inside of f of x would equal x. So yes, it is an inverse. Yes.
I didn't do the exact same thing. I still added I still minus the 2 and put 5 over the, right answer.
Okay, you want to tell me what you did?
I forgot to put, I didn't like did the 5x plus 2.
You just didn't use the parentheses, so you went 5x plus 2 minus 2 minus 2? Is that what you mean?
Yeah.
That's fine. You don't have to. I always do the parentheses when I'm doing substitution because it reminds me I'm doing substitution. If you skip straight from taking the f function and doing this first, that's fine. You're welcome. Sometimes if this is like a negative 5x plus 2, people get kind of confused with the negatives, so I use parentheses to control my negatives. That's really what it's for. But when there are no negatives, they're kind of pointless, so you don't have to. Any other questions on this one? Anybody else still copying this? So for the last one, my f function was this 4x minus 20. And instead of x, we're going to replace it with my g of x. So inside, instead of x, I'm going to have x over 4 plus 5. So then I distribute, and I get 4x over 4 plus 20 minus 20. If I combine my terms, those will cancel out, identity property. For my division, I can use that identity property again. And so, f of g of x equals x. So yes, we prove that they're inverse. Questions on finding of inverse or proving an inverse? So if you go on Google Classroom, you had to do this worksheet, lots of fractions in it, right? Did anybody start this worksheet? Of course not, miss. Why would we practice? Okay. So ready, set, go. Excuse me? On Google Classroom, it's in cycle 3. There aren't a lot of assignments in cycle 3. I posted it after class last time. Practice finding inverse functions. If you get to a problem and you're like, this is too much, go to the next one. Don't stay stuck on one. Because I'm sure a lot of you are going to be stuck on number 1.